So in the previous video, we talked about why does it look like a good idea to re-implement some parts of the Kubernetes in Bash just to have a better understanding and understand that this is not magic, just a well-written application. And we also checked the required components, which will be stored uh, based on the tutorial of the Kubernetes is the hard way, which is the most simple way, I think, to start Kubernetes. So this is what we need, and let's start first a normal application, a normal Kubernetes cluster, and after that we can try to replace the scheduler one with a custom Bash implementation. So first of all, we need the external dependencies, the etcd and containerd. So let's start them. I already generated all of the certificates and some of the configs based on the Kubernetes in the hard way tutorial. And the etcd, it's very simple. It's nothing more, just the etcd. I can delete the previous state just to be sure that we are starting from an empty state. So I have an etcd. I can also go to the containerd. It's even more simple because it's empty. I don't need any configuration right now. Just let's start it. So these are two. And we can continue with the Kubernetes components, API server and controller manager scheduler. So let's go to the API server. We have more. So this is the Cube API server Golang application, one binary, no magic. And this is a restricted set of the parameters compared to the hardware, just really what we needed. This audit path can be interested in the future. All of the others are mainly just the certificates which are generated and a few IP addresses. So let's start the API server. Okay, it started. The interesting part is that if I start the API server, I can just use the kubecontrol, right? So this is admin kubeconfig, which is just generated. Yes, it works. Oh, okay. I have no node, but I have no pods, but the kubecontrol works. So let's go forward and try to start the scheduler itself. The scheduler is extremely simple. I have one configuration here. So the kube config itself is defined to make it possible to connect back to the API server. So I can just start this one. Okay, I don't have controller server. Maybe I should start it even before the scheduler. It can be more important. So controller manager. Let's check the configuration. Yeah, again, we have a kubeconfig to make it possible to connect back to the API server and some cluster EP ranges. So I'm just starting this one too. Okay, let's go back to the map. So I have this one, this one, this one, this one, this one, and I need a node, but I will use the same laptop, so this workstation. I will start a kubelet here and maybe a QProxy. So just go to the magic again, Cubelet. Okay, there are a lot of, not so many parameters, but yeah, I have the same parameters just because I have an SSD and limited number of bytes. And I will use the containerd and CNI plugin for networking. Nothing very special. And I'm using swap. So I'm just turning off this track. So I can have, this requires root permission, right? Because it's supposed to start a lot of things, checking networks, so on. So it's running. If I go back to here, It's not yet ready, but hopefully it will be ready very soon. And until that, I can start the QProxy as well. So let's go to here and let's check what's going on. Oh, QProxy configuration. Yes, IP address range and the kube config. No surprise here. Yeah, and it's supposed to modify the API tables because it's in the API tables mode, so it's better to give some permission. So I have a Kubernetes cluster here, and we can try to deploy an application. Yes, we have a ready node. So just go to this one, and I have a pod here. You can see that I simplified a little bit the configuration with host network, and I have just an Nginx container here. So let's apply and see what happens. Container creating. If I do a void, I can see that it's assigned to the node. So this is what scheduler did. And it's running. Awesome. So I would like to remove this scheduler and replace with a bash script. So let's stop it. But what I'm interested about that, what happened? That what did this scheduler do? And fortunately, we turned on the audit log in the API server. So if I go to the start, you can see that I have an audit log path and I have an audit policy, where the policy is just something that plays in the empty resource group, just log everything. So here I have an audit log. Oh, let's check it in a more formatted way. Oh, better. And we can see that we have usernames, kind, and so on. So the username can be interesting because we have Office API server, but we have also a kube scheduler. So let's try to do a select. Select where the user.username is kube scheduler. Maybe I need this one. Oh no, this one. Yes. So now I have all of the events which are sent by the kube scheduler. So one interesting thing is request URI, and the other one can be maybe the event. Okay, let's check the request URI. So request URI. Oh, we can see that our services applications. So, but I don't know which one of these are important. So let's add a verb. Oh, so there are a lot of lists, list, watch. Yeah, I can understand that it tries to check the persistent volumes and services just to, which might be required for a scheduler decision. But, oh, it seems to be an event create, yeah, so it's just some metadata for either the node or the pods. And this seems to be interesting, right? This is the create itself. So let's check this one. I'm just going back when we are printing out everything and I'm trying to find this. Okay, this is the event object reference. Yes, response status request object. So this is the object which is just sent by the scheduler to schedule the Nginx, right? It selected the OS3 node. But it's not a rocket science. I can do it easily because I have just one node. So it's very easy to decide which node should be used because I have one node. So let's have a template here, which is this one. And here it's supposed to use some UID, right? And this is the name. I can support multiple namespaces, but maybe we can just start with the default. So here we are. We have the template, and the only thing what we should do is just post it at the right time with the right parameters. So we don't have any running. Oh, first of all, I need to kubeconfig and define the kubeconfig of the scheduler itself. Oh, we have no pod, so let's try to apply the same nginx. Yes, it's pending. And we can see that, okay, there is no node here which is selected because the scheduler is stopped. We are in the console where we had the running scheduler. So let's try to check it. This is the pod and we have the UID. So the only thing what we should do is just post it as we have seen in the audit log. So this is a longer command, but what we are doing here is just using the template, replacing the UID, replacing the name, and this is supposed to be saved in a file which will be used by the curl. The curl uses the scheduler secret key and certificate, and I just set it to verbose mode and it's in the unsecure mode, which means that the CA certificate is not configured here. And after that, we are just posting it to the binding. Yeah, I think there should be 2 minus here. Yeah, status, success. And if I check the pods, it's a container created. So it's definitely assigned. Oh, it's assigned to the OS3. Yes, this is very simple because I have just one node. I'm always assigning to the OS3, but it works, right? I don't have the real scheduler. And actually it can be done very easily to check the pods in this phase, because I can do some field selector status dot phase equals, okay, today it's running, but I can do pending. Even I can do with curl because I can check the original request. So this is what I should do with curl to check all of the pending state, and for all of the pods I can just post this binding content. So this is possible to do, and one way to do it is just create a shell script. I have a pre-created version, but it's very simple. It's just creating a TMP file. It tries to get this status phase, which is pending, and it saves it, and it iterates over the metadata name and UID, which are split in the parts, so we can just print out this template. And after that, this is exactly the same command. This is not the most effective bash source, but it can work, right? So I think it's template binding. So just copy this template.binding. And after that, we can just start it and run it again and again. Oh, not shared. Okay. Yes, and every 1 second it tries to check the pending pods, and it will be post binding. So I can use my cluster without a specific scheduler. If you are interested about a more sophisticated scheduler in this rewrite Kubernetes in Bash pull request, you can find a Bash scheduler, but it's slightly more complicated because it tries to use the original logic where we have multiple nodes. Here I don't have any nodes, so it's very easy to assign anything to the nodes because I know which nodes should be selected, the one and only one. So we have a scheduler. This replaced with a shell script, at least in a very specific and limited way. It couldn't support all of the features, but at least one pod can be started, right? So next time we will try to replace either the Cubelet or the controller manager with something which is very similar and see how can we go forward and what parts can be replaced, because we have a lot of features, right? We couldn't support all of them with batch, but it can help to understand what are these features and how these components are working together.